Dr. Carla Abbott from the Centre for Eye Research Australia, part of the Macular Research Unit team. So this is a project looking at high-density lipoprotein, or HDLs, which is a type of cholesterol. And what we're wanting to do is to really understand the composition and the functionality of the HDL molecule, which is very important in age-related macular degeneration. So it's known that the HDL just in the blood of people with age-related macular degeneration is elevated, so it's higher. However, this is different to in cardiovascular disease, where it's actually a protector of cardiovascular disease. So what we need to do is understand why this is, because it's a paradox. So what we think is that there's actually dysfunction in the HDL molecule itself, meaning the composition of how the HDL is made up of proteins and enzymes has changed. And if we can understand that composition and dysfunction in AMD, then we will be able to look at the pathway for AMD pathogenesis and target ways of being able to intervene in that pathway and provide a treatment for people with macular degeneration. So this study came about, it's been a long progress, I guess. So originally our fellow Centre for Eye Research researcher Hitesh Peshaveria was working with our team. So he was a basic scientist working with our clinical group and had this idea that HDLs were really important in macular degeneration. And so we started looking at some basic science together. Unfortunately, when Hitesh passed away in 2017, we were left to carry on without him. But one of my co-investigators, Dr. Manisha Shah, is actually Hitesh's wife, and we've been slowly working towards getting further data and being able to build up a grant so that we can work with patients and really understand what's happening with the functionality of HDL in patients. So we've gone from lab work at the bench through to now being able to look at work in patients. So we'll be recruiting patients to come in, both people with macular degeneration and also control subjects, so people without macular degeneration, and taking a sample of blood so that we can analyse the HDL composition and functionality in the plasma of the blood. And we'll be looking at the differences in that functionality between the people with macular degeneration and the people without, and also within the different severity of the disease, so early stage macular degeneration compared to the visually devastating late stage of macular degeneration. And ultimately, this will show us what it is within the raised HDL plasma levels that is contributing to the development of AMD, and will be able to help us find a pathway that we can intervene at. I trained as an optometrist, and I still work as an optometrist on the weekend actually. And then I did my PhD in vision science at University of Melbourne, and then followed a fairly straightforward career in vision science, looking at both retinal diseases, but also just the workings of the normal retinal circuitry. So I did postdocs at the Safe Sight Institute in Sydney, the National Vision Research Institute in Melbourne, and also the Devas Eye Institute in Oregon, USA, but have now been back at CIRA for the past 10 years, working within the Macular Research Unit and also the Bionic Eye Unit. What we'd like, if we can show that there's differences in the functionality of the HDL molecule, then we'll be able to look at formulations that have already been prepared for cardiovascular disease and look at being able to run clinical trial for a treatment trial. So there's already molecules that are acting on HDL for cardiovascular disease currently in large international trials, and it would be hoped that if we can understand the functionality to a degree that we're able to formulate that for this purpose, then we'd be able to start a clinical trial very quickly off the back of these results, an interventional trial. That could be a viable option, is the way we see it. But we need to see firstly what plays out in terms of the functionality of the HDL in macular degeneration, which is what this project's about, and then we'll be in a position to have those conversations about how we can repurpose or target a treatment strategy off the back of the cardiovascular knowledge. It's very hard. There's less and less pool of funding available from the government institutions such as the NHMRC, so that the success rates are very low, single digits these days, which has changed a lot even in the last 20 years that I've been in research. So, we just really value these opportunities where we have the chance to apply for a considerable amount of money to really make progress in what we would like to do and make an impact for patients, which is why we're all here at the end of the day. So I'd just like to say thank you very, very much to all the donors who have been supporting this project and the other projects also supported by the donors. It just makes such a big difference to us and really has made an important impact on our ability to be able to work on macular disease and provide outcomes that can impact the people living with macular disease in Australia and internationally. Thank you.